Okay, so this is our second video on Thermo, and I'm going to give you a second to pause the video, copy this information down before we start. Okay, you should have paused and copied this down. So we're looking for energy transfer, but we're going to have to also find P, the rate of energy transfer. So those are our two formulas we're going to use. So let's start by writing our knowns down. You should do this every time before you get started. It's too hard to look up here and try to go right to your formula. Always write your knowns down before you start. So first of all, we have the area of our figure over here. Well, it's a square shape, and we know area is length times width. So our area is going to be 2 meters times 1 meter, which is 2 meters squared. Our K stands for thermal conductivity. That's how easy heat passes through a material. This would be something that had already been calculated up for you by using testing to calculate it, and you'd find this information for either the person who's selling you the material or in some kind of table. For our material here, it tells us the thermal conductivity is 0.1. And then it doesn't say the units there, but I'm going to tell you what the units are for thermal conductivity. It's joules over seconds, meters, degrees C. And we'll see how the units work. Then L in this formula is the thickness of the material. The thickness of the material is 0.04 meters. Temp initial. So when we do initial and final, we're talking about as it passes through the wall. On our initial side of the wall, it's 10 degrees Celsius. And on the other side of the wall, once the heat's passed through, it's now 5 degrees Celsius. So our delta temp is final minus initial. 5 minus 10 equals 5 degrees Celsius. It's actually gone down in temperature, so it happens to be a negative there. And then we have little t, delta t. Remember, big T is temp, little t is time. So what is our time rate here? It says 1 hour. Now, this unit is in seconds, so we need to convert this over to seconds because this constant was given in seconds. So you're going to need to make that conversion, and it happens to be 3,600 seconds. All right, so let's write our two formulas down. So we really want to find Q. I don't want to find the change in temperature, so I'm not looking for this one. I'm just looking for straight Q over here. So I'm going to have to use the P's, and I'm going to use two different P formulas. I'm going to use this one right here, which is this one right here. And I'm also going to use this one, which comes from right here. And I'll show you why we need both of those. So again, I'm really looking in my problem for energy transfer, which happens to be Q, but I can't go straight from the MCAT formula. I'm going to have to work with these two. Because this is the same variable P here and the same variable P there, this P is equal to that P. So I can just set these two formulas equal to each other. So this equals this. So I put this formula equal to that one there. Now we're going to go through and fill in what we know at the top. Q, well, that's what I'm really looking for. Delta T, small t, 3,600. K. A. Delta T, that's the big T, that's the temperature. And L is the thickness. I'm not going to worry about the negative because basically we're just saying we're going to lose heat up here. So that's going to mean we're going to lose heat in the end. And we're just going to say this is the amount of heat lost. So we don't need to include the negative. It's just telling us that it's lost instead of gained. So I'm going to drop the negative out of this so I don't have to worry about it. Now, we're just going to use our algebra. And in order to get Q by itself on this side, I'm just going to multiply both sides times the denominator. So that on this side, these cancel, and I'm just left with Q on this side. Now on this side, I just need to multiply across the top, divide by the bottom number to get my answer here, and we're going to round it off. Now we need to check our units. This is why I worried about units when we first did those easier problems, so we could do it with these harder ones. So here I have seconds on top and seconds on bottom. They cancel. Here I have Celsius on top, Celsius on bottom, those cancel. Here I have meters squared, and I have 1 meter on bottom there, so this meter on bottom cancels the squared part, and then this other meter here cancels that meter there. Leaving us with what units? Just these joules here. We know heat is measured in joules, so that's the correct units. And we're done.